Hello, everyone. Are you bullish on Bitcoin? Woo! Okay, good. Gotta get some enthusiasm here because it's the last. I'm the only thing standing between you and partying out on the roof, so I will try to go fast. And I will. This is all in English, but I'm gonna say some stuff in French as well. So let's see. Can I? Okay, so I'm supposed to talk about like most of the stuff I've worked on in the last decade or so. So I'll go quickly as possible. And yeah, so I'm Thaddeus Dryja. I've been working on Bitcoin almost 10 years. Quick summary of some things I've worked on: Lightning Network, discrete log contracts, Utreexo, some other things. Why talk about this? So, a lot of this is, the conference is like, hey, talk about all the things you worked on. And I'm going to speak a little bit in French right now to sort of talk to the French people. So, je peux parler français un peu, mais pas, complètement. Mais il faut que tout le monde, après ça, demande des questions avec moi et parle avec moi sur le tour là-bas, parce que sinon, je vais voler ici, les États-Unis à Paris, et à Paris à Biarritz, et après ça, je vais à l'hôtel et je parle avec Fanquake et Gloria et René, tout le monde que je sais, je parle avec tout le temps, chaque jour, et ce n'est pas quelqu'un de nouveau. Et alors, j'ai porté ici beaucoup de fiches avec les equations, toutes les choses comme ça. Et je peux parler jusqu'à 5 heures du matin parce que mon avion est à 6h30 ou quelque chose. Je vais marcher à l'aéroport après ça. So, okay, so hopefully the only English parts was like shout outs to people. I was just saying I'm mostly talking to the people I hang out with anyway, so like hopefully I can talk to some French people after this. That'd be fun. So yeah, cool. So I'm going to talk about stuff that maybe it's well known, but there's always new people coming into this and learning. And that's something I think about sometimes. And I was saying, like, I worked at MIT until this week, and I've worked with students, and sometimes I think, like, it's kind of unfair. Like, when I learned about Bitcoin, I could mine a couple Bitcoins on my computer with my GPU. And then I talk to students, they're like 18, and they're learning about it. They can't mine a couple Bitcoins, so it's kind of like, unfair. But then also I met a really rich guy a few months ago, and he learned about Bitcoin the same time I did, around 2011. He was just older. He was like 10 or 15 years older, and he had a lot of money saved up. Well, he learned about it when he was like 35. I learned about it when I'm like 25, so yeah, that's just like life. And like, I bought a house recently. I'm like, who owned this land? It's just people who came from Europe like 200 years ago or something. So anyway, it's like, there's always new people coming in. We want to be welcoming as we can. Okay, yeah, and also, there's a big gap, I think. Lots of times people are like, laser eyes and change the world and we'll be rich. And when you're actually working on Bitcoin, and maybe you've seen, if you've seen the other talks today, you just deal with the problems. It's just like, oh, this is a problem, this is a problem. You sometimes lose perspective. So some of the reason I like coming to conferences as well is actually it's kind of invigorating. It's like, hey, people are really into this. Because when you're just working at home or just working in an office, you only deal with the problem. So it's cool to see that people actually like this. Okay, so problems. Here are some of the big problems in Bitcoin. And they're still there, but we've been working on it for a long time. So scalability is a huge one. It's expensive to run. You're paying billions of dollars in electricity and ASICs. Programmability is something that, like, yeah, in Bitcoin, people want it to be more flexible and do more things. Privacy, big problem that is really hard to deal with. Like, I'm kind of scared to work on privacy. That apparently someone got arrested for working on privacy technology. Like, and that's not even like crazy. Like, even I can say, like, the DLC stuff I'll talk about in a minute. There were people saying, hey, you should talk to lawyers before you work on this software. And some of the students I was working with were like, I don't want to work on this. Like, someone said it could be illegal. And, I think it's like so far away from some of the stuff that is like so scammy and people make so much money and do all these scams. And it's like, wait, I'm still worried about like these things? But it does affect things. And I know like other people I know have gotten sued and stuff. And it definitely hurts. So yeah, privacy is one thing where it's like you want to work on it, but it's sketchy. And just general usability. I see lots of people using Bitcoin, but in ways that's like, no, you should run a full node. Just download Bitcoin Core, and they don't. Like, my brother or something. So yeah. So anyway, those are a bunch of the problems. There's some partial solutions that help, and I'll talk about 3 of them. These are the 3 things, some of the 3 things I've worked on recently, or not recently, really. Lightning Network, discrete log contracts, and Utreexo. So this will be sort of mile a minute, and I guess the idea is hopefully make people think about it, and then can ask questions and go drink whatever champagne they give you and stuff after this. Okay, so Lightning Network, that's pretty well known. I think it's cool that the name I choose for it stuck. So Joseph wanted to call it a different name. I was like, let's call it Lightning Network. Oh, hey, it's stuck. Cool. And it's pretty well known at this point. So I don't think I have to explain everything about it. But in 2015, or really 2014 when we started working on it, the general idea of payment channels was around. And even sort of the idea of trying to make a network of payment channels. It wasn't like, totally novel or out of the blue or anything. And there's probably people, I don't know if Christian's around, but people were doing similar work. And at the time, people thought that payment channels were a thing that worked, and they really weren't. There were problems with malleability, problems with being able to keep reusing payment channels. And so, part of starting this was Joseph had ideas about how to do it. I had some ideas, and we, started working on it, how to make it really trustless through intermediaries. And at the time, one of the ideas was, okay, you have these sort of one-way channels where you have, similar to Lightning, you have a funding transaction output, and let's say it has, 10 coins, and Alice can keep paying Bob. And this works because Alice keeps giving Bob something that's better for Bob. So Bob can, and is worse for Alice. And really, in this case, Bob's the only one who can close the channel. Right? So Alice is giving Bob a way to close the channel, and maybe there's a timeout where they can, both get their money back eventually. And Bob doesn't, can close it but doesn't, and leaves it open, and Alice keeps giving Bob more money, right? This seems to make sense and works because Bob's sort of continually getting something that's better for him that he doesn't necessarily want to end. And I always think about the blockchain in this context as the blockchain is where you put data that you don't, how do I say this? The blockchain is where you put data that someone doesn't want everyone else to know, right? So I think about it in if I'm making a payment and let's say I just give you a private key. You won't consider that really me giving you the payment. I have a Utreexo, it's got 1 Bitcoin, I say, here's the private key for it. It's not quite good enough, right? You want everyone to know that I can't use it anymore. And just giving a private key is not enough. So you put it on the blockchain. Everyone knows it. And I would rather that data on the blockchain wasn't there. It'd be great if I could give you coins, but I get to keep them. And no one knows that I gave them to you, so I could maybe use them the next day. But the whole point of the blockchain is we're putting it out there so everyone knows you don't have it anymore. There's data that's not beneficial to you. And so in this case, Alice can keep giving it, and then Bob, broadcasts it to the end. So yeah, it's data you don't want people to see necessarily. You can always share more keys, and something like graph-root is a really interesting technique where you could say, okay, I'm going to send to a key, but it's not that this key will spend. This key can then later sign a new message on who can spend it. So I can keep adding different spending paths. And this was sort of like that. And what I think one of the big ideas in Lightning Network that's not something that people think about as much is revoking a claim. That, I'm revoking something without going onto the blockchain. And so that's, to me, and this is part of the stuff I worked on with Lightning Network spending, where it's like, okay, you have this, the actual script is fairly straightforward. It's, key A now or key B later. And since it's an or, key A also later works. But the idea is there's one key that can spend right away and one key that can spend later. And the key that can spend now is actually given away, right? It's a composite key. You use sort of add these elliptic curve points together. And so the idea is someone gives it up, and by giving it up, revokes their claim on a transaction, right? So, and that's how channels in Lightning Network work. When you're just moving money, not even thinking about routing, just a single channel. Alice says, okay, I have 1 coin, Bob has 9. You can build cooperatively a new state where now Alice has 5, Bob has 5, And then immediately after building this, you revoke your claim on the previous state by giving up private keys. And so I think that was like kind of a really cool idea that, and you can keep doing this for basically ever. Make a new one, revoke it. During the protocol, there's a little time window where you have this sort of superposition, and there's two states, and either is valid, but usually that only takes, a few milliseconds, and then you keep going this way. And so that's just one of the things I wanted to talk about Lightning Network, because it leads into the next thing. I have like one slide about routing HTLCs, because I think there's been a lot of talk about it, so I don't need to go through it, but that's how it works. You route HTLCs. Hopefully, sometimes that works. But yes, that is one of the problems in Lightning Network. Sometimes it doesn't work. So I'll segue to the next part, which is discrete log contracts, which uses a variant of that same idea of like revoking and which states are valid and not. And so this was something I wrote. I was actually developing at the same time as Lightning Network and thinking, maybe this could be used as well for some kind of smart contract stuff. It actually started because I went to an Ethereum meetup it was a Bitcoin meetup in San Francisco. And I met a guy and he's like, I'm working on Ethereum. I'm like, what's Ethereum? This was, 2014 before any ICO or anything. And he's like, it's like Bitcoin, but you can do smart contracts. I'm like, well, what are you doing with it? And he was talking about how you could do these kind of, futures contracts based on Oracle price feeds. And I was like, I bet you could do that in Bitcoin. And he's like, well, how? I'm like, I don't know, but this seems like the kind of thing you could do in Bitcoin, right? And so, it took 3 or 4 years, but then I wrote this. So it's actually a very similar structure to Lightning Network in terms of the transaction scripts, everything like that. You have one funding output and many spending transactions. But the difference is, in Lightning Network, everything's internal to the channel itself, right? To the Lightning Network itself. It's sort of Alice and Bob are sending each other data, and they keep spending, giving each other money or revoking things. However, in discrete log contracts, instead of sequentially invalidating past transactions, all the transactions are invalid, except there's one that gets endorsed by an oracle. And the oracle endorsing it doesn't realize it's endorsing it, right? So a good example of this is Alice and Bob want to bet on the weather. And so, tomorrow's weather, it's a future event that they don't know what's going to happen. If it rains, Alice gets a Bitcoin. If it's sunny, Bob gets a Bitcoin. If it's like cloudy, then they both just get their half a Bitcoin back. And this is not something that you can put into a consensus protocol, right? Like, it's sort of an opinion. You need this third-party real-world data to come in. And so this idea also has been around, and people were working on sort of Oracle things. To me, one of the problems with the Oracle is, and I think people were talking about this just the last talk, like, hey, that Oracle might end up being a regulated entity or something. Or if you've moved all the trust to this Oracle, that does seem like you're reducing the amount of trust needed. But now you've still got this Oracle, right? And so I think to further make this less trust is, okay, let's make it so the Oracle doesn't even know they are affecting any smart contracts, right? Make it sort of this diode where the Oracle is a one-way, transmitter. They're a radio station broadcasting the data, but no one's querying them. No one's asking them to judge anything. That's right. Oracle, and then also you want the Oracle to not equivocate. You don't want the Oracle to be able to say to one person it's sunny and to another person it's rainy, right? You want them to be held accountable. And so it uses the same idea, right? You've got possibly, in Lightning, you're saying, okay, we're like sequentially adding and revoking states. So it's like, okay, here's state 1, I build state 2, and then I tear up state 1 by giving you this new data. And then I build state 3, and I tear up state 2. So now we can have a single state for this contract. With discrete log contracts, same idea, except you build all 3 states when you're building the contract. So you actually build all these different states, exchange them, send them over to the counterparty. They check the signatures and stuff, and they're like, okay. And then you broadcast the funding transaction, and then you wait, and the Oracle actually signs a message. You can use that Oracle signature and sort of stuff it into your own transaction, and now one of these is valid. And you can't really broadcast the other ones. You can broadcast them, but it's exactly the same as in Lightning broadcasting a invalid state, where the other person can just grab all the money. So what's nice about this is it looks kind of the same as Lightning Network channels. You can't even tell on chain that this was happening because it looks the same as Lightning. Although now there's like so many new developments about it. Yeah, so it's not as widely known, I guess. Like people are saying, yeah, it takes longer, but there is lots of development. There's some startups and stuff working on it, open source work, so that's cool. There's a lot, actually, in the last 6 months, year, yeah, a lot of interesting developments about it, about using adapter signatures, ideas about how you could fit up check template verify into this and make it more scalable. A paper like a week or two ago about BLS signatures, using BLS signatures for this, which is really cool. One of the things I worked on recently, like last year with a student, is novation. So one of the problems with discrete log contracts is you don't want to get stuck in the contract. A lot of times people want to like trade things really quick. So you're like, okay, I'm long, I'm long Bitcoin. So I have like leveraged Bitcoin and my counterparty has something like a stable dollar value output. But actually I want out and that terminates next week. But actually I want to trade this. I want to get out. I want to take some profit or stop my loss. If you cooperate with your counterparty and your counterparty's like, yeah, okay, like we can end early, that's fine. Then great, but maybe your counterparty's offline. So a way to non-interactively trade your position to someone else would be really cool. We have a paper that you can do it, you can only do it once though. And then you'd need to be interactive again to refresh it because we need something like SigHash any prevout to be able to continually do it. So there's a lot of cool stuff going on with that. Okay, I have like 12, 13 minutes. And so next I will talk about something completely different. I still think it's so discrete log contracts is more of a flexibility, programmability kind of thing that can do some smart contracts. Maybe it hasn't gotten as much airtime because if you're trying to do smart contracts, there are other, not as cool as Bitcoin platforms and coins that people sort of gravitate towards and can do whatever crazy stuff they want. Obviously, developing in Bitcoin is a bit harder because it's, a bit more constrained for good reason. And Utreexo is sort of a scaling thing that's kind of layer 1, maybe layer 1.5. It's not really layer 2 because it doesn't change too much the general model of Bitcoin, right? It's really, you can think of it as a replacement for the database in Bitcoin. So I've been working on this mostly through the pandemic, so maybe that's also why it hasn't gotten quite as many, not quite as much mind share because I haven't really given many talks about it. I've been working on it for quite a while, but yeah, for like all of 2020, 2021, like you're just stuck at home, right? So yeah, the idea is you don't store the whole Utreexo set. You store an accumulator. And the idea is that like long-term wallets store their own proofs of their own coins. And if you have more UTXOs, well, that's a heavier load for your node to deal with. But that's good, right? Like, so if you're not aware, like UTXOs are where the Bitcoins live, right? I think maybe in the future, if Bitcoin takes over the world, UTXOs will be a slang term for money. It's like, hey, did you send them the UTXO? It's like, this is where all the Bitcoins live. The goal of Bitcoin is to get lots of UTXOs that have a high score attached to them. And so they're pretty small. Like in the actual database, they're variable size. But like, yeah, 70 bytes. You got a 36 byte out point. You got maybe 20 to 32 byte, script pub key kind of thing. And then like 8 bytes for how much they're each worth. And 4 bytes for height, I guess. And I think that's it. So yeah, they're tiny, but there's like 80 something million of them now. And it does go up, but it could go up a lot faster is one of the worries. And one of the things that prompted Utreexo is right now the UTXO set is 5 gigs, not quite. And the blockchain is like, almost 100 times that big. And so people worry about the blockchain size. And that was one of the huge debates like five years ago now? Wow, more than 5 years ago now, the block size debate and stuff. And they're like, hey, we can't just, make the block size arbitrarily large. People won't be able to store it. People won't be able to verify it. But no one really talked about UTXO set size much. And so right now, yeah, you're about 100 times larger for the history. The history is, the blockchain is everything that's happened in Bitcoin. And the UTXO set in chain state folder in Bitcoin core is all the stuff that exists now. So who owns what today? And you can prune, you can throw away the 448 gigabytes of blockchain. If you want, if you're running a full node, you just set pruning and it throws it away and everything pretty much works fine. But you cannot throw away this 5 gig chain state. And actually the 5 gig chain state is more of a bottleneck than the blockchain, because you always have to hold it, and it's level DB, and it's all these really tiny things, so it's a lot of very intense disk IO. So if you're running on like a spinning hard drive, it's like really slow. And we've seen like sort of UTXO set pollution, where like in late 2017, the UTXO set got really large, and we think it's like these exchanges who are sort of managing their wallets poorly and making a really large number of UTXOs, and then like cleaning it up later and stuff. And one of the worries is the UTXO set could get really big. You could grow it by like a gigabyte a month pretty easily. Maybe I shouldn't say this, but like you could. No one's doing it, so that's good. But like you could definitely crank that if a malicious actor wanted to, waste a lot of money to do so. But like, hey, I'm going to double the UTXO set size. They could do it. There's a lot of pollution in like op return is a way to not put stuff in the UTXO set. So one of the things, there's an is unspendable check in Bitcoin. And if you see an op return as the first byte of the script, you say, oh, I'm not even going to put it in the UTXO set. It can never be spent, so I'm not even going to bother putting it in the database. So that's like actually, good. But there's lots of stuff that obviously will never be spent, but it's still in the UTXO set. So like, oh well. But yeah, so the general idea is, hey, instead of my node and your node and everyone's node holding this 5 gigabytes, why don't you keep your own UTXOs, right? So if you have a wallet with 10 UTXOs, it's not that much, right? That's just, a kilobyte or two. And you sort of split it up amongst all the different users. And if you're, Coinbase and you've got like a million UTXOs, like, well, okay, that's their problem. Like they can hold all of those and they're not on my computer, right? Yeah, so, and then the idea behind it was, okay, right now when people spend their money, they attach a signature to proving that it's theirs, right? And that's how you, check the signatures and stuff. This adds a new witness that's an inclusion proof, a proof that the coin exists. And so in the Utreexo model, you'd still be validating every transaction and still be throwing stuff into something that looks like a database, right? You're writing to it and deleting from it, but you don't actually store the whole thing. You're writing to it and then later receiving a proof that, hey, you wrote this into your accumulator a couple days ago and then forgot it. And you can see how this would work kind of like a Merkle tree, right? Basically, if you put the UTXO set into a giant Merkle tree and then people gave Merkle proofs that, hey, my coins are in there. And then you say, okay, your coins are in there, I'll let you spend it. It's a little different, and I'll go real quick. Standard Merkle trees don't support addition and deletion. So Utreexo is a modified kind of Merkle forest kind of looking thing. So real quick, if you want to learn about this, I actually, I did bring papers, and at the Miami conference, I was definitely like drawing diagrams and like moving arrows and stuff for it. Yeah, so adding is actually kind of straightforward. So you keep the root of every tree. Every tree is perfect, which means it's always a power of 2. There's no asymmetries. So the idea is if you have 4 UTXOs, 4 elements in this set, you keep this one root. It's in yellow, orange. If you're adding something, so you're like, okay, I added a new UTXO. Now there's 5 instead of 4. Okay, well, you just keep that separate, right? Now you keep 2 different things. And you say, okay, now I add 6. Well, once you have 6, you can smush those 2 together. And now I say, okay, I have 7. I need to keep all 3 of those. And now I've added to 8. Once you have 8, you can smush those together to 1, smush those together, and now you only need to keep 1 thing. And you keep the trees perfect that way. It's also kind of nice. The number of trees is going to be the number of 1 bits in the binary representation in the number of leaves. And if you think about it, you're like, okay, yeah, 8 is 1, 0, 0, 0, and 7 is 1, 1, 1, and 5 is 101, and 4 is 100. So yeah, like you can just look at the number in binary. You're like, oh, each tree, in that space will have how many things is under it and stuff. So addition actually is it's like 10 lines of code. It's actually pretty straightforward. It's kind of nice. Deletion is harder. What is nice about and the actual thing is we're moving the deletion algorithm to an actual simpler one. I'm giving a very hand-wavy explanation of deletion here. There's actually in this algorithm a lot of kind of edge cases that are annoying, and we're switching to a new algorithm that is a bit simpler and doesn't have as many edge cases. But what's important and works in both algorithms is the proof of inclusion, the proof something exists within the tree, is always enough to allow you to delete it, which is kind of nice. And in Bitcoin, those two things are kind of the same operation. The only time you need to prove that a UTXO exists is when you're deleting it, right? So which is very different from something like Ethereum or something like that, where you're always saying like, hey, here's this smart contract, and I'm like changing it or modifying it or just referencing it read-only. In Bitcoin, the only time you touch a UTXO is this kind of read-delete operation, right? Where you're like, hey, I'm spending this UTXO, I need to read it, get the data, check the signature, and then right after I do that, I delete it. And so that's kind of nice because in Utreexo it fits really well. So when we want to prove, for example, element 2 here, the proof would be 3, 8, right? So in a Merkle proof, like you hash 2 and 3 together to get 9, you hash 9 and 8 together to get 12. So when someone's saying, hey, I'm going to spend 2, I'm deleting 2, they give you 3 and 8. And once you have 3 and 8, you can reconstruct a new set of trees without 2, right? You just say, okay, well, if 2 is gone, I know what 3 and 8 are. That's going to be my new set of trees. I just delete 9 and 12, and I'm like, yeah, now I have a tree with 2 and a little sort of tree with only 1, and now I have 3 leaves, and I went from 4 to 3. Cool, I'm all set. That's a really easy example. There are some harder examples, but it always works. Basically, you're either wait, did I? No, I didn't. Either you have the sort of sibling in your proof, or you have something like on its own in a row, and you can move it into place. So you're able to delete, and it's actually pretty quick. It's kind of nice. It's quantum secure, right? Because it's just hash function. So it's kind of a cool algorithm, I think. The problem with Utreexo, and this also was not my idea. Actually, I think talking to Sipa, Peter Wool at Financial Crypto, we're talking on the beach, and he's like, no, the problem with these ideas is you have to have this bridge node. And I'm like, well, why is that a problem? Because a lot of the other accumulator designs, you would need proofs for every UTXO, and that was very hard to generate, but also to update. And they have to change every time a block comes in. Because although the idea would be maybe, hey, everyone keep track of your own UTXOs in your wallet and sort of send them out, it's not really going to work, right? Because if you're the first person that uses this, you're going to say, hey, I'm using this new cool technology, and I downloaded it, and I've got proofs for all my coins, and everyone give me proofs when you give me your transactions. They're all just going to be running version 24 or 25 or whatever. They're not going to be using this, and you're going to be stuck. You won't be given proofs. So you need a bridge node, at least temporarily, and I think in practice probably forever. You're never going to get everyone to switch to this, which is also nice. Part about this is it's not a fork. There's no soft fork. There's no consensus change. You can start running it today if you want. I mean, there's a lot of bugs, but it will work without any minor knowledge or anything. People don't have to know you're doing it, which is cool. But yeah, you need some kind of bridge node which can provide proofs on demand for every UTXO. So here's sort of the model where you've got full nodes over on that side that are just doing the same thing they do today. You got a bridge node in the middle, and the bridge node appears to be a full node to the full nodes. And it also appears to be this sort of mini Utreexo node to the other ones. So you don't necessarily know that you're talking to bridge node, and peer-to-peer propagates on both sides. But when it sees a block, or when it sees a mempool transaction, it looks up and says, oh, it's spending these 4 or 5 UTXOs. I generate a proof through, I've got that whole Merkle tree, which is 90 million leaves, and it's kind of huge. It's 5 to 10 gigs. But I can generate proofs on demand and throw them over to the other side, and then these guys will consume the proofs. So the bridge node is something that it's extra work to do, but it's not that bad. It's 5, 10 gigs of storage and minimal CPU, and you can totally run it. If you can run a Bitcoin full node, you can run a bridge node, basically. And that was a big difference between Utreexo and other ideas of how to do this, where some RSA-based accumulators or class group-based accumulators have nice properties where the proofs are very small and you can verify things much more quickly and stuff, but maintaining a bridge node is sort of prohibitive. It would need 90 million proofs, and every time a block comes in, you have to update all 90 million of those proofs individually. And that was a real scalability problem. So that was sort of the impetus behind some of the... I'm out. Okay, real quick, some interesting things you can do, some optimizations in Utreexo. There's a lot of locality, and this works in LevelDB as well, where you're hey, UTXOs that just got created are probably going to get spent in the next block or two. And that, so this is a log plot of how long UTXOs live. And so you can sort of see a nice line. A lot of UTXOs live very short lifespans. A lot of them live 0 blocks. They are created and destroyed in the same block, which is, kind of inefficient, but is great for this system because in Utreexo, those UTXOs don't exist. They never touch the accumulator because Utreexo only updates things when blocks come in. It doesn't really deal with the mempool too much. Fun little things about this. You can see there's a bump at 6 because people wait for 6 blocks. I don't know. There's also a bump at 100, which makes the only one that really makes sense because like if you're a miner, you got to wait 100 blocks to spend your money. Then there's also one at 433 and 1,000. So people wait those amount of time to spend their UTXOs. Kind of funny. Yeah. So basic idea, Utreexo can make running nodes small and fast, and that's the goal. Everyone in cores, everyone working on this sort of worries, hey, people aren't running nodes enough. They're trusting these exchanges, or they're using something like Electrum, which, it's pretty good, but you lose a lot of privacy and some security with using these kind of Electrum-based wallets. So you want to reduce the technical limitations to on-chain scalability. Who knows, maybe if it gets really easy to run full nodes with huge UTXO sets and blockchains, maybe you can have some kind of, block size increase. I don't think that's that crazy. I think it's a little concerning that, there were a lot of people with really dumb ideas about increasing the block size. Just because they were dumb people with dumb ideas doesn't mean that we should never talk about it again, but and it actually might make some of the code simpler because you have the ability to sort of get rid of level DB in a lot of cases. And that's the biggest, scariest import to a lot of Bitcoin code. So that'd be cool. There's no way to make money from it, so that may be why there's not quite as much interest in all these startups working on Lightning Network or discrete log contracts. Yeah, Utreexo, I'm pretty sure you can't make money, which is okay. But I think it's more behind the scenes. If it works, people might not necessarily know that it might just be an option in Bitcoin Core, and you're using Utreexo and it's faster and smaller. So there's a bunch of people working on it open source. Myself, a couple people, one in Korea, one in Germany, sort of global things. We have calls every Monday or something. So yeah, come on GitHub, talk to me about it. So I think that's my last slide. We're out of time, but yeah, it's a little hectic. It's sort of trying to condense 8 years into 30 minutes. So that's about a 500 million X compression factor. I do sleep a lot too, so yeah, it's not that. It's maybe only a 200 million X compression factor. But yeah, I think myself and many of the people who have been talking today, we want to get more people involved in Bitcoin research and development. It's really fun stuff. I don't know, am I a maximalist? I don't have any other coins. I don't think I have any. I might have some Moneros, but I think I lost them. I've sometimes played around with other coins, but I'm basically I only like Bitcoin. But I am not as it's gonna take over the world, because Bitcoin is still kind of fragile. I worry about it probably more than a lot of people I know who are yeah, Bitcoin. I'm yeah, I hope it works. So it's still fragile, but I really think that knowledge and learning about it strengthens it, because one of the big attacks I worry about, and in the block size debate thing was happening, that if you can redefine what Bitcoin means, that's really scary. And then that's a way to attack it. So I think, having lots of people who use Bitcoin know about it really well. And I say about my dad, he didn't want to buy Bitcoin because he was I don't understand it. And I was well, you should still buy somebody. Then he retired a couple years ago. And then the next time I saw him at Thanksgiving, he was so who determines the generator point on the elliptic curve? And I'm whoa, okay. He just read everything about it. And then, a couple months later, he's okay, I'm going to buy some Bitcoin. I think it works. I think I understand it. Maybe not everything, but yeah, no, this works. And I was okay, that's cool. I respect that. He still should have bought some in 2013 when I told him, but hey, he bought some later. And I think that's an important part, where if you really understand it and you know what's happening, it's much more robust to any kind of attack, because it's not just you're running the software, you sort of know what's going on, because there's going to be all sorts of weird things where people are going to try to redefine it or propose bad things and stuff. So yeah, I hope learning about it is part of owning it. Okay, so I'm out of time, but yeah, come bug me after and questions and stuff, and merci beaucoup. Thanks. Okay, yeah, we can do Okay, we can do questions. And then y'all also, if you want to do less broadcast gossip questions after, just come bug me. So we can do some questions now. I don't know.
Hello, thank you for your talk. Thank you for coming all the way down here in order to educate us. And you said that you wanted more people involved in educating people and working on improving Bitcoin protocol. Where should one start?
Okay, so where do you start? So I can pitch my own thing. So I taught a class at MIT a couple years ago, and there's YouTube videos. So if some people like them, that's cool. I actually didn't so it's I just should put this on the slide. I think if you just search OpenCourseWare Bitcoin or OpenCourseWare, it was the course was mas.s62. But I think it's not too hard to find. I taught the class, and then they took a while to sort of put the video on YouTube, and that was around when coronavirus started, and so I didn't really think about it. But then I went to the Miami Bitcoin conference and stuff, and all these people were like, "Hey, I saw your video," and I was like, "Oh yeah, those videos." I sort of didn't remember, and then I looked at them again. I'm like, they're not the greatest videos. I think the class was pretty good. I think I did okay, but it's sort of the video is just in the back of the classroom, right? So I'm like, I should try to make better ones maybe. So maybe at some point, maybe in the winter, try to make new videos or something, update it. But I think that can give some good ideas. There's also online, when I started back in 2011, there was Bitcoin Talk. It's not as good anymore. I guess IRC, there's the PR Review Club, Bitcoin Optech. I would say in general, there's a lot more documentation and courses and stuff. So yeah, keeping up with Bitcoin Optech, to some extent, keep up with the mailing list, go on IRC. That's where people are talking about this stuff, and people are still really open, to people asking questions and stuff. I randomly get messages on Twitter, and probably more than half I just delete because they're scammy, whatever. But if people ask actual technical questions, and yeah, maybe you could Google it and find it, but I'll answer because it's I know it, and it saves some time. So I'm pretty open to that kind of stuff too. So yeah, sure. Any other?
Hi, thank you for your talk. I really enjoy. I really like the energy you put in your talk, and to show us how passionate you are about this subject. But I'm passionate too, because we were together at the BitDev, and it was really a fruitful discussion. I really enjoy it. For the education, maybe I would recommend too a video from someone called Curious Inventors on YouTube. He made a really great animation of Lightning, for example, and even once about Bitcoin, but it was really 2013, so it was really a while ago, but the videos are really good, very animated, and it's really beautiful to understand stuff, I think, so maybe you should try that. And yeah, so now my question is a bit about Utreexo, and really wondering, because yeah, the solution is to compress the Utreexo set, and 5 GB doesn't seem much for now. But you say it will make it faster, so often the problem is IBD. The initial block download is really the bottleneck for full node adoption, I think. And I was wondering, what do you think about because there are trade-offs everywhere, and I bet that because you have to transmit the proof of existence of Utreexo, then maybe the bandwidth is higher.
Yes.
But I guess you win something with RAM management or memory, because you can fit the Utreexo in the whole memory without worrying about being it too large. So what do you think, and what's the state of it?
Yeah. So the download can be larger, up to twice as large, right? So because the proofs, you also are downloading these proofs. If you want to do full IBD and you have no caching at all, it ends up being almost a terabyte total. So 500 gigs of blocks, around 500 gigs of proofs. So that's worse, right? So if you're really bandwidth constrained, maybe don't do this. So my example is, if you're on an airplane with a really fast new laptop, this will make it worse. But in many cases, people have extra bandwidth and lower hardware. So if you have a Raspberry Pi connected to fiber optic internet, this will help a lot. So yeah, there is a bandwidth trade-off. But the sort of idea here is, I didn't, but the caching is actually pretty good. We have really nice ways to cache ahead of time that reduce the proofs to not to, maybe 20 or 30% more. One reason it's faster is you can parallelize much better. So we have sort of fun code where you basically can have like worker threads that are verifying a block, because they're sort of self-contained. You can say like, here's the the initial state of the Utreexo tree. Here's the block and proof, and tell me the final state. And that's, a megabyte or two, and you can just throw it to a worker thread, and it'll just return a bool, like, yes, this worked or didn't, and also return a, next one, and you can sort of match them up. So you can, however many cores you have, you can validate in parallel. You could, in theory, do that with Bitcoin today. It's just you need to move this 5 gigabytes as well. So you can actually validate quite a bit faster, and also it doesn't touch your disk. So even with SSDs, you are in many ways bottlenecked by disk I/O. And so the fact that even if you're just, you're still using a quad core or 8 core or whatever, it ends up being faster because you're not touching disk as much, if you have the network bandwidth. So yeah, if your network bandwidth constrained and you have a slower internet connection, this doesn't help as much. But the other thing you can do, which I don't talk about in the GitHub and stuff, you can just skip the whole thing, right? Because the now chain state is like less than a kilobyte, fits on a QR code or whatever, you can just hard code like a checkpoint kind of thing into the binary and just skip everything or do it later. Which there's, are people going to do that? Maybe, I don't know. So like in some cases that might be okay, or there's work on doing that with Bitcoin today, like assume UTXO and stuff. So I don't know if that's the best solution. People are probably going to do it. So you can just say, look, I'm not going to do IBD. I'm going to skip it and go to like a couple of weeks ago and then work from there. It's a different trust model, right? But you can also sort of say, okay, I'm going to skip IBD, just verify the last couple of days, and then in the background I'll sort of probabilistically or validate a little bit behind or something. So that can let you do very fast startup and then defer the validation if you want. So those are some of the techniques that we're looking at. So, cool. Okay, any else?
Well, thank you. Seeing that it's a small room, I'll ask the geeky question, because I think everybody here is a geek too. In fact, you brought it up yourself. Well, first, I just wanted to also back up what the other fellow said, is I didn't know you had so much energy for educating, so thank you for that. And the only time I ever saw you was on your YouTube video on DLCs, which is true that the video wasn't a bit in the back of the room, but yeah. Basically I thought what was great there was that, what people always say, you'll never solve the Oracle problem, and it's almost solving it by the fact that you blind the Oracle to who's making a bet. So he's blinded to the value of his value. So I thought that was a great idea. But the geeky question is the one you just brought up yourself, because ECDSA is my weak point. So what is the answer to your father's question? How do you determine the generator point? Oh,
Yeah, it's weird. So the actual SecP 256K1 generator point is something's up, right? Because if we need Sippa or someone here, he knows, but it's something like half the generator point is a point very close to the origin, or something weird. There's something weird about it, where it was clearly not randomly determined. But we don't know, and it shouldn't matter, right? It should be any arbitrary point on the curve should be just the same, and everything should be fine. And we don't have a good record of here's this NIST thing. So it's something weird though. Maybe we'll find out.
For every signature, we use the same generator point.
Yeah, everyone uses, it's just part of the specification. The curve is y squared equals x. -7 or +7, yeah. It's a real simple, and then you have this prime factor, but the actual determination of the generator point, better would be some kind of, let's take the hash of the first 10 digits of pi or something, and set that as the x coordinate and try to find a y coordinate for it. It's okay, here's it. So there's sort of nothing up your sleeve. But there is something up the sleeve of the SecP 256K11, where I think, if you can find, there's a point where that's very close to the origin, and if you double it, you get the generator point. And it's okay, they got it some weird way, but I don't remember. I'm sure, I don't know, do you know? Yeah, maybe someone here knows, but it is it is like a kind of interesting, fact, but it shouldn't matter. According to the math, any point should be fine, and we all just use that, and like all of our public keys are the ratio between that generator point and our public key, right? All our private keys are ratios between the generator point and our public keys. So should be safe. Hopefully it is. We'll see. Okay, cool. Sounds good. All right, well, thanks. It's almost retail du soir, so go party.